This time, let's evaluate the Laplace transform of t. We are going to emphasize here t first so that we can use this representation into the other forms containing the variable t. So we are going to solve for the representative expression for this using this formula for Laplace transform of any function of t. So we are just going to do it like this. The Laplace transform of t, meaning this would be our f of t. It will be substituted here. So this is equal to the integral of 0 to infinity of e to the power of negative st. Then you will have here t dt. We are going to solve the integral of this from 0 to infinity, where we consider s as an arbitrary constant. Okay, and because we are just going to look into the integral of that in terms of dt. However, here we cannot integrate this because this is not the du of e to the power of u here. Because if this is e to the power of u, your u is negative st, the du with respect to t is negative s dt. But you have here t, right? So unlike the previous example for 1, where we added here arbitrary constant s and of course neutralize it with negative 1 over s here, we have here letter t. So we cannot do that. Hence, we are going to integrate this by parts. Okay? So integrating by parts, we are going to let t be equal to let u. Okay, let u be equal to t. That would mean du is dt. So that would mean this together with dt here, that would be our dv. So we'll have here our dv is equal to e to the power of st dt. So by integrating dv, you're also integrating e to the power of negative st dt. So as mentioned, for this to be integrated, you're going to make it e to the u du. So you're asking for the integral of, the derivative of st with respect to t. So you will have here e to the power of negative st, and then you will have here negative s dt. Okay? So that you can actually integrate that. But of course, you need to neutralize that with 1 over s here, so that this and that is just equal to 1. You're not changing the actual value. So it's negative. So v is negative 1 over s. And this here is actually, the integral of this is e to the negative st itself. So all of this, let's now plug in here, because the integral of u dv, as we can integrate this, we are using integration by parts, is uv minus the integral of v du. And take note, we are using the same range 0 to infinity. So this is now equal to your u, which is t, times your v is negative 1 over s e to the power of negative st. And take note, this has the range of 0 to infinity because it's part of the range here, minus your integral of v, negative 1 over s e to the power of negative st, times your du, which is dt. 0 to infinity as well. Okay? Because you can rewrite here t, the negative 1 over s e to the power of negative st, again 0 to infinity. And then we can now rewrite this with 1 over e to the power of st using the law of negative exponent. So we have here 3 factors now. Okay, so 3 factors now. And for the second term, where we are taking out negative 1 over s, so you will have here 0, infinity, e to the power of negative st dt. But for this to be integrated similar to this, we actually need arbitrary constant negative s to our dt, which will again be neutralized by negative 1 over s here outside. Okay? Now look into this. This term here, as t goes from 0 to infinity, this actually, the entire expression will approach to 0. So with that, this entire first term, since this will approach to 0 as this expression or t approaches infinity, this is 0 itself. Now, you will have this here form minus So you will have your minus, okay, 1 over s squared, okay, because you have negative times negative here. And then the integral of this is e to the power of negative st, again the same, 0 to infinity. Okay, so let's continue. Now, so this would become negative 1 over s squared, 1 over e to the power of st, again law of negative exponent, as it goes, as t goes from 0 to infinity. So you will have here, starting with infinity, 1 over s squared. Then you will have your 1 over e to the power of s times infinity. Again, as this approaches to infinity, or as t approaches infinity, this becomes 0. So it returns to 0 entirely. But the second, minus negative 1 over s squared. You have 1 over e to the power of s times 0 for your t. This will just be equal to 1. So you have minus negative 1 over s squared times 1 over 1. So generally, the Laplace transform of t is just negative times negative, positive 1 over s squared. This is the Laplace transform of any or of an expression t, and this will be used later on to generalize as well other forms of functions with t, like let's say 4t, let's negative 5t, and so on and so forth. But this is how it goes for the representation for the Laplace transform of t, as I mentioned, 1 over s squared. Thank you very much for watching.